Hello, televiewers. Welcome to the GCE Maths panel and the Maths 24 Super Channel. In this particular lesson of this A-level series, we are looking at the parity of functions. The parity of functions, whether the function is even or odd or neither even nor odd. Please don't forget to click on the subscription button and to visit our blog for more lessons. And if you have to watch this lesson, you are advised to watch this lesson to the end and leave your comments. You can equally have these notes by visiting GCE Math Panel Classes online and clicking on A level. Stay tuned as we roll. The parity of a function describes whether a function is even or odd or neither even nor odd. If f of x is equal to minus f of minus x, if f of x is equal to f of minus x, then we say that function is even. So this is the condition for a function to be even. And for example, if we have a function which is given below, to show that that function is even, this is what we are going to do. So the first function, we have f of x equals x squared. To show that this function is even, we look for f of minus x. F of minus x will be equal to minus x all squared, minus x all squared, and this will give us x squared, which is equal to this f of x, because f of x is x squared. Since f of x is equal to f of minus x, we say this function is an even function. Therefore, this function is an even function we have shown as required. And secondly, if you have g of x equals 1 over 1 minus x squared, to show that this function is even, we look for g of negative x, and this case will give us 1 over 1 minus x squared, but minus x squared is the same as, let me see, minus x all squared is the same as x squared. So this gives us the same function g of x, as we can see, and therefore this function is an even function. This function is an even function. Another example, we have f of x equals 1 minus the absolute value of x. To show that this function is even, we are going to look for f of minus x, and this will give us 1 minus absolute value of minus x, and this is equal to 1 minus absolute value of x, which is the same as f of x, and we say that this function is as well even. Let us take example 4 and see if the function is even or not. So given g of x equals x cubed minus x, g of minus x will be equal to minus x, all that's the power 3 minus x. And this will give us minus x cubed plus x. And this is not equal to g of x, as we can see. This is not equal to g of x, and therefore this function is not even. If the function is not even, does it therefore mean that it is odd? No, we cannot conclude that. We are going to check if it is odd, and if it is neither even nor odd, then we are going to give a conclusion that it's neither. So whenever a function is not even, it does not mean that the function is odd. Let's look at odd functions. Also, if f of minus x is equal to minus f of x, take note of these signs. F of minus x or f of negative x is equal to negative f of x, then if this condition holds, we say the function f is odd. If this condition holds, then the function f is an odd function. Let's take this example. Show that the functions below are odd functions. So show that the functions below are odd functions. The first one, you have x cubed. Okay, here we have odd, please, odd, not even. All right, so we have this first function, f of x equals x cubed. So we start by looking for f of negative x. F of negative x will be equal to negative x all cubed, which is equal to negative x cubed. And this negative x cubed is the same as the negative of f of x, because f of x is x cubed. Can you see? This is x cubed here, which is f of x. So this function is the same as the negative of f of x. So from here, f of negative x is the same as negative f of x, and this condition holds. This condition holds, implying that this function is therefore an odd function. So this is an odd function. Let's say another example, guys. We have g of x equals x minus x cubed. So we start by looking for g of minus x, and g of minus x will be equal to minus x minus x cubed. And this gives us minus x plus x cubed. We can factorize out the negative sign, or can factor it out. Factor out the negative sign, we have minus into x minus x cubed. And what we have in brackets now is equal to g of x. Can you see this, guys? So what we have in brackets now is equal to g of x. So we can write this as minus g of x, and minus g of x. So this is the same as minus g of x, and therefore this function is an odd function because g of minus x is equal to minus g of x. Therefore, this function is odd. We take more examples on these odd functions. 3, we have f of x equals minus 2x. F of x equals minus 2x to show that this function is an odd function. So f of minus x will be equal to minus 2. That will be equal to minus 2 into minus x, and that will be the same as you can multiply and bring out the signs. So we can send the 2 inside. If you bring the 2 inside, we are just adjusting, unlike expanding and then we start doing the reverse process again, it's going to be lengthy. So we can just bring the 2 inside the brackets. So this gives us minus 2x, and this minus 2x are f of x. So we can replace this minus 2x by f of x, and this gives us minus f of x. Therefore, in this case, f of minus x is equal to minus f of x. So what's the conclusion again, guys? The function f of x is odd. And we have this other one, f of x equals 1 on x. F of minus x will be equal to 1 on minus x, which is minus f of x. Therefore, this function is also an odd function. What happens if these two conditions fail? Let's find out. Let's find out what happens if the two conditions do fail. Let's take this. Let's take this. All right. So, if f of minus x is not equal to f of, let me see, if f of minus x is not equal to minus f of x, or this one should be positive in brackets. I'm sorry about this typing error. Let me just do the adjustments. So if f of minus x is not equal to f of plus x, here is plus. It's not equal to f of plus x, here we have plus. And f of minus x is not equal to minus f of x, then what's going to be a conclusion? A conclusion is going to be that this function is neither even nor odd. So if these two conditions fail, then the function is neither even nor odd. So let us see an example of a case like that. Okay. So f is neither even nor odd. Example, we have shown that the functions below are neither even nor odd. So we have these two functions. Let's start with the first one. Let's look for f of minus x. F of minus x is equal to, give us 1 plus x. This 1 plus x is not equal to f of x. And it is not also equal to, so this function is not even, and this is not equal to f of minus x2. So it's not also odd. Therefore, this function is neither even nor odd. Look at the second function. G of minus x will give us 3 plus 4x. And this is not equal to g of x. Neither is it equal to negative g of x. Therefore, we also conclude that this function is, so negative g of x. So this function is not even and not odd. So this type of functions are neither even nor odd. Type of functions are neither even nor odd. So we can have some questions and some functions here like this. Also look at these functions and see if they are even or odd. Our next lesson is going to be on injective, surjective, and bijective functions. injective or one-to-one functions. Yeah, they most call it into functions, surjective onto, and both into and onto functions. That's the next lesson. Stay tuned and don't forget to share this video with your friends and click on the subscription button or visit our blog for more materials. Stay tuned and bye bye.